Hi there, welcome to this physics tutorial. We're going to solve the problem shown. Now, be sure to pause and rewind whenever you need to. If you need to stop and read the problem or jot down some notes or just go back and review something. So we start out and we want to first figure out the average time. It gives us 3 different times every time we drop that rock. So I'm going to start by listing everything I know. And I'm going to use delta t, that symbol, that triangle, stands for delta, it's the change in time. And my average time, once I figure that out, is 3.067 seconds. Now that's the average time for all 3 trials. And since I'm estimating the height of the bridge, I want to use just one time, the average time. Now, it's asking me to find the height of the bridge, which is essentially finding delta y, or the vertical displacement. And then it does tell me that we're dropping it, so we can assume that the initial vertical velocity is 0, or meaning it's dropped from rest. And it also then asks me to find the velocity at which it hits the ground below. That's my final vertical velocity. Now, the reason I'm using the subscripts y is because this is a free fall problem, something that's falling through the air in what we call free fall. It's only acted upon by gravity. And so this only uses the vertical or the y motion. So when we look at our equations, we're going to look for the ones that involve y. So now that we have a list of everything that's given to us, as well as what we're trying to find, let's search for an equation that will help us get there. So to start out, to find delta y, or the vertical displacement, we're going to use the equation here. It's one of our kinematic equations. It says delta y equals the initial velocity times time minus 1/2 times g times delta t squared. Now notice how I picked the equation that has y's in it because we are in free fall. And that one also includes a negative sign plus g for gravity. Remember, free fall is only acted upon by gravity. Now, because our initial velocity is 0, I can cancel out that first term, and that will actually cancel out all of this because 0 times anything is 0. And then I can go ahead and I can actually calculate my delta y. Now remember, gravity is 9.8 meters per second squared here on Earth, and the time, our average time of all 3 trials, we found was 3.067 seconds. And don't forget the square, that's really important. When I plug this all into my calculator, I get a height or a displacement of minus 46.09 meters, which tells me that my cliff has a height of about 46 meters. And that's answering the first part of the question. Now to answer the second part, the velocity at which it hits the ground below. So the second equation that we can use is another one of our kinematic equations, and it's the final velocity equals the initial velocity minus g times delta t. Just like before, the initial velocity is 0, so that zeroes out. The final velocity is what we're searching for. Gravity is the same, 9.8 meters per second squared, and the time again is the average time of all 3 of our trials. When I multiply this all together, I get negative 30.06 meters per second, and that makes sense that it's negative. Negative implies for vertical motion that we're falling down. And so because we are falling, that implies negative. And that makes sense because we got a negative velocity. So that's how you solve these equations. Remember, for free fall, we need to use the equations that contain y's instead of x's. Those are also the equations that have g for gravity, because in free fall, the only acceleration is that due to gravity. See if you can find some other problems similar to this to practice these skills. Good luck!